Yellowstone if it erupts in a maximum eruption. It can literally tear the guts out of the United States of America.
The question, is Yellowstone gonna blow?
Supervolcano generates the biggest explosive eruptions that we've ever seen.
Yellowstone's volcano could explode any minute now after 600,000 years of silence, sparking real fear. Deep below the park's stunning views, this giant is rumbling awake as scientists spot shifting magma. This scary shift might mean a massive blowup that could destroy vast areas and mess up the world's weather. Park officials are racing against time, trying to figure out what could set off this ticking time bomb. What if it erupts? Join us. Let's uncover the urgent warnings from Yellowstone. Yellowstone's hidden threat. Park authorities are closely monitoring this shifting magma. This leads to more questions about what might trigger an eruption and how much time we would have to prepare. The last eruption left a huge crater, destroyed large areas, and affected the global climate. People are worried that a new eruption could be even more damaging. Should we evacuate the park? What would that mean for the many visitors who come every year? But that's not the worst part. Scientists are learning more about the situation every day. Let's dive into the latest discoveries by Yellowstone officials about this active, moving magma. Deep under Yellowstone National Park, a strong and powerful force is at work, marked by nearly 10,000 geothermal features that create its amazing scenery. These natural wonders are caused by the intense heat and pressure from deep within the earth, making the ground rise and fall like the breathing of a giant creature. The park covers parts of Wyoming, Idaho, and Montana, with most of Yellowstone and its volcanic features located in northwestern Wyoming. Under this massive volcano is a reservoir of molten and semi-molten rock that causes the surface to bulge and sink as it moves into a magma chamber deep below. Since 1923, volcanologists have been tracking these movements, noticing a slow increase in activity. This suggests that the forces beneath Yellowstone are not quiet yet. But here's the thing, it's not just about the ground moving. The possibility of an eruption has far-reaching implications. Between 2004 and 2009, the ground in Yellowstone rose steadily by about 25 centimeters. Then in 2010, it started to sink, causing many people to worry about the possibility of a volcanic eruption and how powerful it might be. Yellowstone is a hotbed of geological activity with very old rocks dating back to the Precambrian period, which is over 541 million years ago. The landscape has been shaped by big geological events like the formation of mountains, volcanic eruptions, earthquakes, and ice ages over the last 66 million years. To the north and east of the park is the Absaroka Range, which formed about 50 million years ago from multiple volcanic eruptions. Long ago, much of the western United States was under the ocean, with areas of sand dunes, tidal flats, and wide plains from the Precambrian to Mesozoic eras. The impressive Rocky Mountains came into being through mountain-building processes that happened toward the end of the Mesozoic era and the beginning of the Cenozoic era. Yellowstone National Park, with its deep geological history and intense volcanic activity, is not only a beautiful place to visit, but also a potential threat to its surroundings. The story of the Yellowstone volcano started millions of years ago when the western part of North America began to stretch out. This stretching created the present-day basin and range region, with valleys and mountains running north to south, including those around Yellowstone. Volcanic activity in the area began about 16.5 million years ago, near what are now the borders of Nevada, Oregon, and Idaho. As the North American plate moved southwest over a reservoir of molten rock, it left behind a 500-mile path marked with over 100 calderas. Yellowstone's past hints at the powerful forces still shaping its future. The molten heart beneath Yellowstone's beauty. About 2.1 million years ago, as the North American plate shifted, Yellowstone moved closer to this underground pool of molten rock. This remains a key factor behind the park's geothermal features today. The presence of magma just below the surface highlights the volcanic nature of the entire Yellowstone region. Imagine a small lump of molten rock. It forms because of the intense heat from deep within the earth, which melts the rocks in the upper layers. When hot magma rises, it creates pools of rock that are both liquid and solid. As the Earth's plates move over these heated spots, they cause a series of volcanic events. Interestingly, the Yellowstone volcano we know today didn't form during the initial volcanic activities in the area. Instead, the hot spot beneath Yellowstone has been spreading volcanic material across Idaho's Snake River Plain as the North American plate has been shifting west for the last 16.5 million years. Close to the surface of Yellowstone, there are two large zones filled with this semi-molten rock. The intense heat from the nearby magma pool pushes the ground above upward. Over millions of years, this process has shaped and continues to shape Yellowstone. The pressure on the Earth's crust has created new cracks, leading to increased earthquake activity. These cracks reach down to the magma pools, allowing molten rock to escape through these openings. When the pressure is released, volcanic gases explode out. These eruptions sent massive clouds of ash and gases into the air, creating fast-moving flows of hot debris that changed the landscape. The ground above the magma pools sank, forming what we now call Yellowstone's first caldera. But this wasn't the worst part. This event was one of the biggest volcanic explosions ever recorded, affecting an area over 5,790 square miles and reaching as far as Missouri around 2.1 million years ago. The amount of volcanic material released was 8,000 times more than the 1980 eruption of Mount St. Helens. About 1.3 million years ago, another big eruption happened along the edge of the first caldera. The Yellowstone caldera we see today was created by a third massive eruption around 640,000 years ago, followed by 80 smaller eruptions. One of these smaller eruptions formed the west thumb of Yellowstone Lake about 174,000 years ago. After these huge explosions, the caldera and nearby areas were covered with thick, sticky flows of rhyolitic lava, along with smaller flows of basalt lava. The most recent of these flows, the Pitchstone rhyolite flow, is located in the southwest part of Yellowstone National Park and dates back 70,000 years. But this wasn't the end. Imagine most of the continental United States once being buried under a thick layer of ash, gases, molten rock, and volcanic debris. Some of this material even traveled as far as Louisiana. These past eruptions of the Yellowstone supervolcano caused massive collapses, swallowing forests, mountains, and other landscapes, creating large depressions known as calderas. The Yellowstone caldera is one of the most famous. Today, Yellowstone National Park draws countless nature lovers. However, this peaceful landscape holds the potential for incredible natural events. Within the Yellowstone caldera, pressure from the magma below has formed two uplifted areas, the Sour Creek Dome and the Mallard Lake Dome. But these domes are just the beginning. They lie above magma at depths of 3 to 12 miles. As the levels of magma and fluid change, these domes rise and fall. Yet these aren't the only features affected by the shifting magma beneath the surface. The shifting ground of Yellowstone tells a story of ongoing change. The restless giant awaits. Over the past 100 years, the entire bottom of the caldera in Yellowstone has moved up and down. The center has been pushing upward and tilting southward. This movement has led to noticeable changes around Yellowstone Lake. The southern shores have sunk, submerging trees in water, while the northern side, near the fishing bridge, has become a sandy shoreline. Yellowstone might look calm now, but signs of its violent past are all around. The last major eruption happened 640,000 years ago, and its effects are still visible today. In the Lava Creek Tuff area, you can see layers of hardened volcanic ash that settled after the explosion. This is a clear reminder of the immense forces below, waiting for another chance to erupt. Yellowstone National Park is a treasure trove for geologists, thanks to its many steaming pools and hot springs fueled by underground magma and fluids. The Norris Geyser Basin in the park has over 500 hot springs and geysers that change their behavior every day. But this isn't the most interesting part. The landscape is always changing. It's far from static. For more than 20 years, an area near the basin has been moving up and down in a surprising way. Researchers are eager to understand what's happening. Studies by the Cascades Volcano Observatory and the U.S. Geological Survey show that Norris has been a hotspot for underground shifts for a long time. Detailed studies using satellite radar and GPS data from recent decades have revealed that in the late 1990s, a massive magma rose beneath Norris. The magma trapped fluids that then burst upwards, weaving through the rocky layers above and causing the surface to swell. But that's not where the story ends. When these fluids found paths to other areas, the swollen ground relaxed and sank back down. Right now, these magma-borne fluids are just a few miles beneath the surface, indicating that underground activity is still going strong and ever-changing. Recent studies show that the Yellowstone supervolcano, which last erupted 640,000 years ago and created the Yellowstone caldera, isn't more likely to erupt now than before. However, something unusual is happening. Steamboat Geyser in the park has been erupting more often than ever recorded. These geological changes might slightly raise the risk of big hydrothermal explosions in the Norris Basin area due to underground shifts. While these changes might sound alarming, remember that Yellowstone National Park is always changing. The geological forces shaping this area are fascinating for scientists. Although they often change without warning, they make Yellowstone a unique and intriguing place. Understanding the geological structure of Yellowstone is tricky because it's quite complex. Looking beneath the surface presents challenges, but experts agree that recent ground movements are caused by new magma coming in and fluids releasing from past eruptions. Michael Poland, who leads the Yellowstone Volcano Observatory at the U.S. Geological Survey, explains that we're just starting to understand the dynamic nature of the Norris Geyser Basin. One surprising discovery was a large magma conduit under Yellowstone, which plays a key role in moving molten rock and intense heat from deep within the earth. To understand how seismic waves move through the area, researchers from the University of Utah set up a network of seismic sensors around the park. They discovered a massive 3,600 cubic mile structure shaped like a banana and partly made of molten rock, located more than half a mile underground using 3D seismic imaging. New discoveries reveal unexpected secrets beneath Yellowstone's surface. Yellowstone's hidden giant. This structure is known as Yellowstone's magma chamber and is part of a larger magma plume. This plume not only supplies the shallower magma, but also stretches deeper into the earth, about 400 miles down, according to plate tectonic theory. This discovery challenges previous beliefs that Yellowstone lacked a significant magma plume and is supported by new seismic data. But this isn't the most surprising part. The 3D images also showed that the source of the magma plume is much closer than previously thought. Instead of being 1,700 miles away, it is only about 125 miles from an upper mantle transition zone. This changes earlier ideas about where it originates. Robinson points out that, aside from the main magma source, other fluids like melted snow might gather in certain places and sometimes leak out in different spots. The team thinks these fluids from the magma are now just below the surface in the Norris Geyser Basin. In the wild and fascinating Yellowstone National Park, centuries of geological activity have created hydrothermal explosion craters scattered across the land. These old craters were formed under intense pressure that heats up the water. If the rock cracks, this pressure can escape suddenly, causing violent steam eruptions that are hard to predict. Though it's rare, a new explosion could happen anytime in the Norris Geyser Basin, especially if fluids gather near the surface. However, Jurison notes that predicting such events is tough because the rock structures are complex and always changing. Still, the research team doesn't suggest keeping tourists away since the chance of explosions is pretty low. Also, the research group is looking into whether the recent increase in eruptions at Steamboat could be due to more magnetic fluids. Even though Steamboat had similar activity back in the 1960s and early 1980s, the researchers are curious why this geyser is more active than others. Jurison thinks that while the evidence linking magma intrusion to the activity at Steamboat is indirect, the timing seems to match up. The team plans to analyze the chemical makeup of the emerging fluids to see if they come from the magma. Meanwhile, the park itself is still seismically active, shown by a 3.3 magnitude earthquake that shook Yellowstone's southern area on August 31st last year. So could the Yellowstone volcano erupt again soon? It's possible, but very unlikely to happen in the next few centuries. If a smaller eruption were to occur, it would probably involve lava flows and a typical volcanic blast, triggered by a series of earthquakes concentrated in one part of the park as magma pushes upward. But this isn't the worst part. In the rare event of a much bigger super eruption, the signs would become very clear. The park would see significant seismic activity, possibly taking weeks or months for the earthquakes to crack the rocks above the magma, leading to an eruption. What if a super eruption, 1,000 times stronger than a typical volcanic blast, were to happen, it would release over 240 miles of material, lasting for weeks or months with ongoing activity. The lava flows would cover a 40-kilometer radius within the park, and about a third of the ejected material would reach the atmosphere, with most of the damage coming from volcanic ash, made up of broken rock and glass. The calm of Yellowstone hides a history of powerful eruptions, a volcanic threat to North America. Imagine the northern Rockies covered by 3 feet of volcanic ash, turning the land into a wasteland that stretches across several states. Rocks and pieces of glass would be thrown miles into the sky and spread all over the country. The effects of such a huge volcanic explosion would be terrible. It wouldn't just damage buildings, it would also harm people, animals, and plants. Even a few inches of ash, which could cover much of the country, would ruin farmland, block sewage systems, and make electrical transformers stop working. This explosion would be so big that North America would have to stop most of its air travel. It would also change the world's weather. When a volcano erupts, it releases sulfur particles into the air. These particles can block sunlight and cause temperatures to drop for a while. For example, when Mount Pinatubo erupted in 1991, it made the Earth's temperature drop by about 1 degree Celsius. In a similar way, the Tambora eruption in 1815 caused such a big cooling effect that it hurt farming all around the world. Although there are no clear signs of such an eruption at Yellowstone Park right now, we can't ignore the chance that it might happen in the future. The ongoing geological activities remind us that the threat is real, even if it's currently dormant. It could wake up at any time with serious consequences. The chance that Yellowstone's volcano will erupt in any given year is very low, even lower than the odds of an asteroid hitting Earth. Even so, we can't predict exactly when Yellowstone might erupt again. We don't know if a major eruption will happen soon, but for now it's safe to enjoy the beautiful scenery of the park. Big eruptions have happened in the past and will happen again in the future. But for Yellowstone, one of the biggest volcanoes in the US, whether it will erupt again is uncertain. It's possible that Yellowstone might never have a 4th major eruption. The ongoing geothermal activity and the cooling of the Earth's surface could eventually cool the underground magma chamber until it turns into granite. Also, the volcanic hotspot that fuels Yellowstone is slowly moving northeast, while the North American tectonic plate shifts in the opposite direction. Over thousands of years, this movement could lead to the hotspot moving away from Yellowstone, possibly ending its volcanic activity. But these changes would take millions of years, which is hard for us to imagine. Earth has been around for a very long time, and geological processes take a long time to happen. Although a big eruption at Yellowstone isn't impossible, many factors make it unpredictable. As people, we can't see the future, but we can prepare for different outcomes. Having emergency plans ready, knowing the risks of living near a volcano, and staying updated on signs of potential eruptions are important steps. By taking these measures, we can be ready for whatever the future brings. So while the chances of an eruption are low, the unpredictability of such natural events keeps scientists and residents on their toes. If a massive Yellowstone eruption is inevitable, should people be compelled to relocate? Share your thoughts in the comments, like, and subscribe for more.